Scientists have long debated whether a massive asteroid impact triggered Earth's earliest known megaflood event. New geological evidence suggests that an ancient impact may have released enormous volumes of subterranean water. Asteroid collisions generate immense shockwaves that can fracture the crust and displace underground reservoirs. Some researchers believe this process could have caused widespread flooding billions of years ago. The hypothesis is based on deep-sea sediment layers containing impact-related minerals like shocked quartz. These minerals form only under extreme pressure conditions, such as asteroid collisions or nuclear explosions. The Chicxulub impact, which ended the dinosaurs, triggered massive tsunamis and long-term climate shifts. If an even larger impact occurred billions of years earlier, it could have caused planetary-scale flooding. Scientists analyze crater formations to determine if past impacts correspond with signs of ancient water displacement. Some of Earth's oldest craters show evidence of erosion consistent with sudden, catastrophic flooding. An asteroid impact can instantly vaporize ice deposits, releasing torrents of water into the atmosphere. If early Earth had underground oceans, a deep impact event could have forced water to the surface. This theory could explain why some ancient rock formations appear to have been rapidly submerged. Researchers have found traces of water-altered minerals in impact zones dating back over 3 billion years. Hydrothermal systems created by impacts may have also sustained early microbial life in submerged environments. If asteroid-induced floods occurred, they might have played a role in shaping Earth's first oceans. The discovery of similar impact-related flooding on Mars suggests a common planetary process. Martian craters like Gale and Jezero show signs of ancient water flows linked to past impacts. This raises the possibility that asteroid-triggered floods were a universal phenomenon in the solar system. Scientists use computer models to simulate how impacts could displace massive amounts of water. These models show that even a moderate-sized asteroid could unleash megafloods lasting thousands of years. Such events could have altered atmospheric conditions and influenced early climate cycles. The idea of an impact-driven flood challenges traditional views of Earth's early hydrological history. Some theories propose that volcanic activity or gradual climate shifts played a greater role in early flooding. Others argue that asteroid impacts could have jump-started the water cycle by unlocking trapped ice. If true, this would mean Earth's first great flood was not a slow process, but an instantaneous event. Geological records indicate some of the planet's oldest river channels may have formed after impact events. Similar features on other planets support the idea that asteroid-induced flooding shaped early landscapes. Astrobiologists are interested in whether such events could create temporary habitats for primitive life. If asteroid impacts released water, they might have also delivered key organic compounds for life. The study of ancient impacts helps scientists understand the conditions that led to early biosphere development. Future deep core drilling missions may provide more evidence linking asteroid impacts to massive flooding events. Some scientists believe large impacts were necessary to make Earth habitable by regulating its water cycle. The debate continues as new research refines our understanding of asteroid-driven geological transformations. Whether Earth's first great flood was impact-driven remains one of the most intriguing questions in planetary science.